This class. Okay, so now we gotta get everything cleared up for tomorrow now. Yeah, didn't hear me nothing. Oh yeah, okay, I'll pass it on. Okay, what are we on? Number 4. This is the last one. And just to let you know, we're going to start trig B. This is the first time in many years that we've only taken a test on trig A. Because usually we combine them together or something. So this test should be kind of easy because it doesn't contain a lot of material. Okay, number 1. Say what? See, so there's going to be 1 or 2 problems on graphing. So you're not going to really graph, because you have to know what the graphs look like in order to answer the question. Right? So like this. You're not going to draw a graph, but there's going to be questions about that.
How many questions are there?
Were you here 1 minute ago?
No.
See, that's why you don't know. 1, 2, 3. 2 pi, 1, -1. What does this do to the graph? It multiplies the x's by 6 over pi. So if you multiply this by 6 over pi, this becomes 12. This multiplies the y's by 2, and then you got to reflect it over the x. So cosine looks like this, so now it's going to look like this. Right? And keep on going forever. So it says, write a sine function that has the same graph as this. Now, of course, there's an infinite number of answers, right? You guys know that, right? I'll take any one that's correct. So, what do you want to do?
Add 2 to x.
You want to do a positive sine graph or a negative sine graph?
Positive.
Like, obviously, the amplitude's not going to change, so it's 2, right? The period doesn't change, so it's going to be pi x over 6, right? The only difference is you're just going to be shifting it, right? So a sine graph starts at 0, goes to the maximum, and then goes like that. So if you want a positive sine graph, you start it there, which means shifted 3 to the left, so x plus 3, that would be correct. Or if you want to start it over here, you shifted 9 to the right, so you can put that, right? Or you could add any multiple of 12 to that, right? Yeah.
The answer's different.
There's like multiple answers.
Yeah, but are they different?
Wait a minute, time out. Didn't I say reflect it over the x-axis? I didn't reflect it. That's why, that's the problem. You guys wait until I finish almost the whole problem, then you say something. Anyway, you're supposed to reflect it over the x-axis, which I didn't do. So the graph's supposed to look like this. There. Anyway, so sine starts over here and then it goes up to the maximum, right? So shifted 3 to the right, or you could have shifted it what? Where would it start again?
9
Right
to
there.
the right.
No, you got to shift it 15 to the right.
15.
Yeah. Or you could have shifted it, what would be right there? What would this be right there? 6 to the left. So you could also have x plus 6. That's why there's an infinite number of answers.
So it's -2.
No, those are the positive signs. What if you made a negative sign? -2 sine pi over 6. Now, a negative sine graph starts from here and then goes downward, right? So if you started here, that's like shifting it 3 to the left, so we could have had this. Or a negative sine graph would start here, and then see it goes down. So you could have shifted it, what is that, 9 to the right, so you could have had x minus 9. And so forth and so forth. Trig functions are periodic, they repeat themselves. So be prepared to answer 2 questions about graphing. In fact, why don't we do the other one now, which is number 3. It says find the domain. Why? Well, I would suggest you draw the graph and then just look at it. Okay, what does cosecant look like? Doop, 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 doop. Doop, doop. So sine looks like this, and then you just hump. And again, some of you still not drawing asymptotes, and I just don't understand it. Okay, so this multiplies the x coordinates by 2 over pi. So if you multiply this by 2 over pi, this becomes 4. So that would be 2, that would be 0. And that multiplies the y coordinates by 3. And then you have to shift everything up 1. So if everything goes up 1, so this point starts at 4, and then you hump up. And then this is negative 2, and then you hump down. So the range is going to be from 4 above, and then from negative 2 down, right? Now what about the domain? Well, the domain is all real numbers except where you have vertical asymptotes, because that's where it's undefined, right? So it's going to be x such that, now if you don't know how to write the k notation like I have on the bottom, then don't write it. Just go like this. X cannot equal ... negative 2, 0, 2, 4, 6, ... Just list them out and then put ... on both ends. Right? If you don't understand how to write the k notation, then don't write it. Do that. But you got to make sure you have enough numbers here that you can see the pattern. So if anybody writes this tomorrow, that's it, like this. ... 2, ... How can you tell anything from that? That's why I draw the graph. See, that's why I don't have to make you draw a graph, because you're going to draw it anyway to answer the question. Unless you really know what's going on, yeah? And then number 2. Okay, tomorrow there's going to be, I think there's 3 proof-like problems. Like this. Number 2. Secant x plus 1 over secant x minus 1 minus secant x minus 1 over secant x plus 1. Simplify this in terms of cotangent and cosecant. So where do we start? Subtract the fractions?
Change it.
Or do you want to change everything to sine and cosine? What do you want to do?
Multiply everything by cotangent.
Oh, what do you want to do? You got to do something.
Multiply the tops and bottoms by cotangent.
I didn't hear you.
Multiply the tops and bottoms.
So what? Just simplify now or change it to sines and cosines? Okay, so make a least common denominator. Whenever you're adding and subtracting from fractions, that's what you do. You make a least common denominator. Okay, so what's going to go on the top? Secant x plus 1 squared minus secant x minus 1 squared. Then what? Multiply it out! Secant squared x plus 2 secant x plus 1 minus secant squared x minus 2 secant x plus 1 all over secant squared x minus 1. Hey, you somebody! Secant squared x minus 1, that's tangent squared. And then on the top, doesn't this cancel this? And that cancel that? Minus the negative is positive, so on the top basically you just have 4 secant x, right?
Oh, wait.
Time pop, let me look at the algebra 1. All I did is foil that and foil that. That's all I did. I don't like using the word foil.
Okay, so you're
But a lot of you guys don't put this parentheses here and then you get in trouble, yeah? That's what happens. Okay, now what? I'm trying to change everything to cotangent and cosecant. I don't even see them there. So what should I do? Maybe now I should change it to sines and cosines. What do you think?
yeah.
Okay, so on the top, what do we have? 4 over cosine divided by tangent squared, which is sine squared over cosine squared. And then when you divide by a fraction, that's like multiplying by the reciprocal, or you want to multiply top and bottom by cosine squared. That's the same thing. So you get 4 cosine all over sine squared. Now do you see the cotangent and the cosecant? Okay, let me ask you this. What is cosecant?
Sine.
1 over sine. So isn't sine squared the same thing as 1 over sine? And then cosine over, here, I'll just write it like this then. Isn't this the same thing as that? This is called lomi, massage it. So this becomes 4 cosecant x, and that's cotangent x, and then you're done. So can you do 3 of these tomorrow? See, you guys gotta practice doing this on your own. You copy it off the board, you don't get any better. You gotta practice. Okay, and then the meat of the test, 4. Okay, now I'll tell you, there's no graphic calculator tomorrow. Everything's gonna be done by hand. Okay, so 4, what's the first one? Oh, you guys can do the meat. Okay, 4H. That's the only one. Are you sure? I might have questions tomorrow when I actually do the homework. E and G. You can't ask questions when you have a blank paper. Or let me see that you try. Copying down the problem is not trying it. That's 12. This is trig A1. Okay, what do you want to do here? There's only pretty much one thing you can't do. Change everything to sine. If you don't know anything tomorrow, just change everything to sine and cosine. Even though you get -6, at least you're going to feel good that you did something. Okay, now how do you get rid of the fractions? Multiply through by? So you get 2 sine squared equals 3 cosine plus 3. Now what? You want to try to make everything just one variable, right? So what? Change that to 1 minus
Shouldn't that be
cosine.
cosine there?
Where?
Right there, 2 sine squared cosine.
Why is it sine
Is-
squared?
Yeah.
Shouldn't
2 sine cosine times.
You're
sine.
multiplying through by cosine.
Yeah, and it's
Then should-
because it's 2 separate things. So 2 sine cosine.
Playing together.
That's what?
Wait, no, I can see this coming from.
Just kidding, just kidding.
Really kidding. I don't get it.
That's a time sign. This is times. It's not plus, it's times. Yeah. If you multiply both sides of the equation by cosine x, when you times this, the cosines cancel out and you have 2 sine sine, which is 2 sine squared. This is multiplication. You can cancel. Okay, let's when you multiply this times this, don't the cosines cancel out? And then what's left? 2 sine sine, which is 2 sine
So
squared.
cosine doesn't go to sine.
No, they cancel.
So the first
When you multiply a times 1 over a, the a's cancel out.
Yeah.
A.
Oh, got it.
What about the? It's like you're multiplying a times b times 1 over x.
Why am I explaining algebra 1? What
Sure,
don't you
sure.
get? What don't you get?
Because it's like a times b times 1 over a.
Because like
It's
you
cancelled.
distribute.
So why isn't it
cosine to
a
both.
b?
You don't distribute when you have a times.
That's what he's thinking. Because I was thinking.
So you're telling me 2 times 3 times 4. So that's 2 times 3 times 2 times 4 then. Because I gotta distribute the 2. Is that what you're saying? There's no distribute. You're just multiplying 3 things together. Wait a minute. From trig A1, haven't we been like multiplying both sides of the equation by the LCD? There's been no problem until now. 2 minus 2. Got this all on video too. Okay, now look, everything's all cosine, and I bet you it's gonna factor. Now tomorrow, if it doesn't factor, you did something wrong. Because there's no calculator. So factor it, 2 cosine. You guys wanna make u substitution?
Yeah.
Or too bad I'm not.
No.
Why would you?
Well, because some people feel more comfortable if you let u
For
equal
fun.
cosine x. Anyway, so setting each factor equal to 0, you get cosine x equal -½ cosine x equal -1. These are numbers you're supposed to know already, right? But some of you are confusing the families, I noticed on the quiz. This one here is the pi over 3 family, right? It's 2 pi over 3 and 4 pi over 3. Distribute. Okay, H, is that it?
No,
Now
no.
tomorrow, there's one inequality now. I'll tell you right now, the number, problem 10. That's an inequality. That's like 4, where's the G? Everybody can do G?
No, E and G.
Wait, I'm gonna come around with my grade book now.
E and G.
Yeah,
E
you
and G.
do.
Yeah.
Do it.
I never did them. E and G.
G.
E.
You cannot ask questions if you didn't attempt the homework. I already told you that.
Well, I didn't ask.
Wait a minute. This looks eerily familiar like the one I did last week. Let's look at trig 8.3. Oh, I see what happened.
You just switch.
This one was sine squared and that one was cosine. So I just switch them and then all hell breaks loose.
Yo.
What do you mean, yeah? What's the procedure for solving inequalities? You make one side 0, and then you factor it. Okay, but before you can factor it, you gotta change that to 1 minus sine squared. So 2 minus 2 sine squared x minus sine x minus 1 is less than equal to 0. So putting in the ascending order, you get the sine x plus 1. This is exactly the same numbers we had last week. We want the first term positive, so multiply through by -1. Was that too confusing, Callahan?
No, that's good.
And then don't forget to change it. And then it's gonna factor, it has to. 1, 1. Some of you still have problems with factoring for some reason. Okay, now here's the hard part. Now tomorrow, if you get to here, you're only gonna get 1 point. That's it. Because everything's pretty much, in fact, I don't know if I'm gonna give you any points here. You gotta test the number line. Every single year, some students, they don't even have a number line. If I don't see a number line, automatic fatal error. Okay, now what do I put on the number line? What makes this factor 0? Sine of what is a half?
5 or 6. 5 minus
Okay. Sine of what is -1?
3 times.
Okay, now you get 1 point. Now you have to test each region.
0. Plug in 0.
Okay, plug in 0. Sine of 0 is 0. So 0 minus 1 is negative. 0 plus 1 is positive. Negative times positive is negative. But if that's negative, that has to be negative, right?
Yeah.
Because if you plug in 0 and 2 pi, you have to get the same result. So Mr. Park, if I get that wrong, I can get that one wrong too. That's right. Okay, what's a good number to plug in here? Pi over 2. Sine of pi over 2 is 1. So 2 minus 1 is positive. 1 plus 1 is positive. Positive times positive is positive. And this just alternate them.
No.
Pi is a good number to pick. Sine of pi is 0, so that's going to be the same thing as this one, right? Okay, we're looking for greater than or equal to 0. So that means all 3 of these points are included, and greater than would be there, and then make sure you write that in your answer, yeah? And make sure you write it correctly. Pi over 6 is... You know, every single year, they forget about this one. And the correct word is or. If you put comma, you're going to have to take off 1 point. And means no solution. And means the intersection. What's the intersection of this and that? Because comma doesn't mean anything. The proper word is or. Because or means the union. Do we have to go over
No.
union and intersection?
Yeah.
And then, let me ask a question. How many people have prisms? When you guys did number 6, did they come out to that answer? No, because somebody came in this morning and their prism, when they did it on their prism, it didn't come out exactly with it was close to those numbers, but it wasn't exactly.
Can we go over E? Like how you figure out
You lucky! She's asking for E.
how like sin x equals cosine x? Because like, I just didn't get that. Because I got up to that point, but I didn't know how to figure out which
Okay,
round
E.
to take.
Sine, and do you guys know when to square both sides?
Yes, sir.
Like on 4D?
Yes.
Don't worry, I gave you a hint tomorrow. That's so sad. Okay, how do you solve this equation? Well, first step, now you can use the distributive property. You know why? Because there's a plus sign there. You guys think you just can distribute anything you want? Okay, can I factor that right now?
No.
No. Oh, you guys want to factor? You factor when one side is 0, so if you want to bring the 1 over, you can, but okay, you got to be able to factor this. So what do you want to do?
Can you just
change this to 1 minus cosine squared, or change that to cosine squared plus sine squared.
Could it
You
use,
substitute.
Wait, what? What?
oh, couldn't you make sin x equal cosine x? Cause this is sin squared x plus cosine squared x equals 1. So shouldn't the sin x have to be the cosine?
Say that again?
So,
Change sine x to cosine x?
yeah. Or like it's, okay.
Well, why not just change this equal sign to greater than?
No, stop.
And let's change the 0 to 5.
No, like, because wouldn't that be like that since like I was.
No, you can't do that. You gotta make one side 0, and you gotta factor this side. You gotta factor it. You cannot substitute whatever you want. I don't like sine x, I'm just gonna regular x.
Like it comes out to be, because if you use the property thing, like
What
plus
property?
sine squared x plus sine squared x equals 1.
Right?
So like if it's sine squared x plus sine x times cosine x equals 1, can't sine x equal cosine x?
No. No, that's just an identity that you can use to replace things with. You cannot change the equation. You know what I'm talking about?
Yeah.
Okay, so you can do two things. Change that to 1 minus cosine squared, or change that to cosine squared plus sine squared. You gotta do something.
No minus x.
Okay, so change this to 1 minus cosine squared. Either way though, the ones cancel out when you do that. Now you can factor it. You can factor out a cosine, and what's left? Sine minus cosine. Now it's factored. Set each factor equal to 0. So either this is equal to 0, or this is equal to 0, which means sine equals cosine, right? Didn't we have something like this on Friday? You know, when Mr. Berg, there was a negative sign in front. Cosine of what angle is 0? Boom, boom. Boom, boom.
Pi over 2.
3
3 pi over 2.
Okay, where on the unit circle is sine equal to cosine?
Pi over 2.
No.
Pi over 4. Pi over 4.
Yeah, it's right there.
Yeah.
Pi over 4, 3 pi over 4. And remember the two other ways I told you to think about it? Divide both sides by cosine, and then you get tangent x equals 1. Where is tangent x equal to 1? Pi over 4, 5 pi over 4. Or you can divide both sides by sine x, and you get 1 equal cotangent x. Where is cotangent equal to 1? Pi over 4, 5 pi over 4, right? So no matter what, you're going to get pi over 4, 5 pi over 4.
But what if cosine x equals 0, then you couldn't divide by cosine x, so how come you can, like, you know? Like, why can you, what if,
Oh, because Mr. Park, you said that if you cancel a variable from both sides, you lose solutions. Is that what you're talking about? How come we're not losing solutions?
yeah.
But I'm not canceling it out. See, like over here, I'm not canceling cosine x from both sides of the equation. I'm just transforming them into different functions.
No, but he's right. Like, you don't know what x is, so what if x is 0? Like, or cosine.
But then that won't be a solution then, would it?
Like, it wouldn't be a solution anyway, so.
So you have to put it back in.
No! You just do. Why are you guys coming up with this cockamamie things? Just do regular math like you were taught from Algebra 1. We're not making, I'm not like making up new rules or anything. These are the same rules we learned from Algebra 1. You can add the same thing to both sides of an equation. You can subtract the same thing from both sides of an equation. Boy,
Could you like, instead of a number line for x, could you make one for sine and then just imagine
oh, like look at a unit circle kind of thing. Yeah, you can, but then in calculus next year, you're gonna want to make a number line because this is gonna be part of your justification. You know when you take an AP exam. Why you don't want to make number lines?
like, it's easier the other way for me because then you don't have to like test every point.
Oh, I know how to thwart that. Okay, but what if the equation like is like a little more complicated than this one? That's how I thwart it. And number 5, okay, I'm not gonna, these are graphing calculator problems. How do you solve any equation or inequality on your calculator? You make one 0, it's like 0, you graph it, and then you just look at it. Where does it cross the x-axis? Now No, you guys are lucky because you know problem 5A and 5B. I never had answers until last year. Because that was like the first problems I checked on the homework. Maybe we should have a graphing calculator problem.
No.
Why not?
Because
That's the easiest
Oh,
thing
yeah,
to do.
that's-
You make one side zero, you
yeah,
graph it,
yeah,
and you
yeah.
see where it crosses
Oh
the
wait,
x-axis.
no, wait,
We
it's
have to
weird. It
know how to
won't
use
graph on mine. Like, look,
Oh,
check
no.
it. Oh, I left my calculator at home.
Okay, any last questions? Now is the time to bring it up.
So is there gonna be a graphic calculator?
no, right?
No. What? So it is different. I think that's something to do with the prism then. There's something wrong with it.
Wait, who has a
No,
TI?
I don't think there's something wrong. I think they program it.
Better.
Maybe they don't use the least squares method. What's that?
What is that?
Maybe but they're using a different technique to compute the regression, the sine regression curve.
My graph annoys me. I hate
So wait a minute, you prism people, since nobody spoke up, that means nobody with the prism actually did number 6 then.
Morris.
it.
I don't know.
Okay, then you know what? Maybe we should have a graphic
No,
calculator
no,
problem.
no, no, no.
No, the TI doesn't work.
No.
It doesn't work.
Yes, it
No, it
does.
doesn't.
It's like
Check in
my
TI.
For which one? Okay, which one? Which one?
It's even for
No, no, tell me which one.
No, anyone.
Everything I try to graph on.
Okay,
it's always-
5A. You know what I think it is? You're not punching it in correctly.
No, we are.
No, you're not. No, you're not.
I'll
I
bet-
know
I'll bet
already.
you a test point.
Okay.
No, wait, no, do that.
Actually, but I-
Okay, make one side 0 and you graph it on your calculator. First step, make sure your calculator's in radian mode.
Radian mode.
Okay, if you're not in radian mode,
How do you make a tangent?
so this is what, y1. Where's the cotangent button, Mr. Park? There is no cotangent button.
What over?
You either change that to cosine over sine. Oh, that's why, Mr. Park was just looking for the cotangent button. Or you change that to 1 over tangent. Which one you want to do?
1 over 10.
Okay, 1 divided by tangent minus 4. Now remember, cosine squared, you have to punch it in as cosine quantity squared now. So you have cosine of root 3x quantity squared. That's how you punch it in. And if you were smart, you would make x min 0 and x max 2 pi. Right? Because you're only solving it between 0 and 2 pi. You graph this on your calculator, and wherever it crosses the x-axis, those are your answers.
Could you not?
Now, if you have a prism, see, this is where the prism is better. Because you just g-solve the 0, and then the first one comes out, and then you press it again, and the next one comes out, and the next one comes out.
Could you not?
Okay, I just took a glance at your calculator. Did you make x min 0 and x max 2 pi?
Yeah.
No, you didn't. I saw it!
Mr. Park, you should just not put this on the test.
But you don't have to do any thinking.
Yeah.
You just graph it and look where it crosses the x-axis.
But we don't want you to spoon feed us.
So then where do you get math?
You might as well just
Press the
not put it.
window button. Press window. X min is 0. X max 2 pi.
Mine says, oh, that is too
Okay, now press the graph button. Wherever it crosses the x, yeah. So wherever it crosses the x-axis, those are your answers. So calculate the 0 and boom, you're in business.
Well, do we have questions with this?
No, too late already.
Hey, Mr. Park,
Yeah, no, but there were several people that came in for help this morning. They didn't punch it in correctly over here, right here.
Park, you know the order over there? Do you need the outside parentheses?
Wait, let me
Can you
look.
put the-
Wait, let me look.
put the
Yeah.
square, like, you can just put the square like right outside the.
No. If you put this square over there, that means only this part here is going to get squared.
Oh,
You sure?
No, because you already closed it, right?
Oh, yeah,
You already closed it, right?
It's gonna square the whole
Because
thing.
you closed it already.
So it's
The
gonna
root 3?
Yeah.
You already closed it within the cosine
So it's
function,
gonna-
right?
So you're telling me if you do this, then that should be right?
Yeah, it should.
Should it?
No! Because then this is going to get squared.
But you already closed it, right?
I'll close something.
No, really? It doesn't work that way? Okay. I guess better safe than sorry.
Which brings, like I said, if you don't punch it incorrectly, right? Because your calculator is only doing what you tell it to do. Anyway, I think the test is pretty easy.
But that's what you said.
No, but no, for real kind, it's easy.
You always say
No,
it's
yeah, I always say that, but no, but this time for real, it's easy.
That's what you said the other time. You said for real this time.
The only problems is you like don't know your Pythagorean identities or your trig values or your graphs,
Exactly.
or you have bad algebra.
You're assuming too much.
This is pre-calculus honors. We are elite. We are the mathematically elite in the state of Hawaii, if not the nation.
I don't know.
Yeah, the bell's gonna ring in
Speak quick.
2 minutes.
Speak quick.
Oh yeah, let me test back this. Yeah, some of you need to make adjustments for tomorrow. Halftime adjustments.
Well, there's no speed part on tomorrow.
No.
Mr. Park, can I have my test then?
Yeah, you know what I suggest for some of you? Maybe some of you should, like at the beginning of the test, draw the unit circle or. Yeah, no, I don't have time now.
No. Like there.
No, we got less than 2 minutes.
That way if you get lodging first. I'm serious, right? Yeah, I'm serious. Because some kid like choked on one of these, so now there's a hole on both ends, so he gets stuck in your
It's a very small.
like swallow it. Yeah, it's so good.
Okay, this row is just minor.
I wonder if
adjustments.
it's really good.
Minor adjustments.
Hey, how do you do so good?
Steady, is that?
Oh, I gave it back.
I don't know who's turning right after
Adjustments. Who sits here? Kang. Minor adjustments. Minor adjustments. Adjustments. Adjustments.
How do you do better than me? What the hell is this?
Adjustments.
And